Hello. In today's lesson, we're going to focus on theoretical yield, actual yield, and percent yield. Before we start, let's think about what the word yield means. You've probably seen yield signs when you're driving. That means to give way. But in this case, yield means what you get. It means how much of something you get, you make. That's what it means. So we're going to be talking about theoretically how much you should get, actually what you really get, and something called percent yield. Let's define these three terms. So theoretical yield, I've written down the definition. Theoretical yield is defined as how much of a substance you make in a reaction if all the limiting reactant is used up. So write that down. How much of a substance you make if all the limiting reactant is used up. That's what, in theory, how much you can get is what theoretical yield is. And sometimes this is called, I don't know how often, but it could be called your expected yield. Usually it's called theoretical. So now let's define actual yield. Actual yield is how much you actually really make. So in this case, all the limiting reactant may be used up, but you may not, your actual yield will usually, almost always, not equal your theoretical yield. Your actual yield can never be more than your theoretical yield, and usually it is less than your theoretical yield. Why? Sometimes there are side reactions that go on that may use up some of your products. Sometimes all of your reactants don't react, so that would be another reason. So your actual yield can never be more than your theoretical yield, and it's usually less for a variety of reasons. Finally, we have percent yield. And you're going to calculate your percent yield. That's going to be your actual yield divided by your theoretical yield. And to make it a percent, we multiply it by 100 to put it in percent form. So that's the definition of percent yield. We're going to work with all three of these terms in our problems going forward. Here's a sample problem. You're going to calculate theoretical yield and percent yield for this problem. You have it on your paper. Adipic acid, I can't read this, hold on. Okay, I fixed my eyes. So we have here adipic acid, which is used to make nylon. And you can make adipic acid, here it is, 2H2C6H8O4, that's the formula, from a reaction between cyclohexane, which is C6H12, and oxygen. And this is the reaction that makes the adipic acid, which is right here. You have water as a side product, water vapor, water gas. So assume that you carry out this reaction with 25 grams of cyclohexane, and that cyclohexane is the limiting reactant. So here they're telling you that cyclohexane is the limiting reactant. In the problems you have on your homework set, you have problems like this where they don't tell you which one is the limiting reactant, and you'll have to use your BCA table to figure that out. The first question we have to answer is, what is the theoretical yield of adipic acid? So I have created a before, change, and after table. Oopsies. And I know that I'm starting with 25 grams of cyclohexane, so I'm just going to make a notation over here, 25 grams. Made my question smaller so I can have more room. So I need to figure out how many moles of this cyclohexane, this limiting reactant I have, if I have 25 grams. So I'll do that up here. I have 25 grams of C6H12, and I'm going to multiply that by its molar mass. So for every 1 mole of C6H12, how many grams do I have? Let's calculate that. I calculate that as 84 grams of C6H12 for every 1 mole. So now I'm going to figure out how many moles I have if I have 25 grams. So if I had 84 grams, I would have 1 mole. I'm going to have less than 1 mole now. 25 divided by 84 is 0.2976. We're working with 3 significant figures in this problem somewhere here. I'm going to keep it at 4 for right now. So 0.2976. I actually hate significant figures as much as you do. And these are moles of C6H12, so we'll put that here. This is, we'll do it in purple, 0.2976. So let's go back to our question, which you can read better on your paper, but it says that the cyclohexane is the limiting reactant, and we're going to look for the theoretical yield of this. So in the theoretical yield, all this has to be used up. So that means my change is going to be minus 0.02976 moles of that, of the cyclohexane. All of it has to be used up. That's the definition of theoretical yield. All your limiting reactant is used up. In this problem, nobody's asking me about oxygen, so I'm not even going to pay any attention to it right now unless I have to go back, but there's for another question, but no one's asking about oxygen. Oxygen's not the limiting reactant, so I'm ignoring it right now. What I am asked about is the theoretical yield of adipic acid, which is this thing. So, I started with 0 moles. How many moles am I going to add? Well, for every 2 moles of cyclohexane, I produce 2 moles of adipic acid. So, for every 0.2976 moles of cyclohexane that I used, I will have to make 0.2976 moles of adipic acid. It's a 2-to-2 or 1-to-1 ratio. So I can just put over here plus 0.2976 moles of adipic acid. So this is in this case, I didn't have to do a molar ratio problem. I didn't have to do a side thing because 2-to-2 is 1-to-1 is minus this plus this. They're the same. So let's write down here, I have 0.2976 moles of this thing, adipic acid, and again, no one's asking me about water, so I'm just going to ignore that for now. The question asks, what's the theoretical yield of adipic acid? Does it ask me to answer that in moles or grams? It does not. However, theoretical yield, unless you're asked for it in moles, is always calculated in grams. Yields are calculated in grams, oopsies, because we can't measure moles. We don't have a scale to measure moles. So yields are always calculated in grams. So in this case, now I'm going to take my 0.2976 moles of adipic acid, 0.2976 moles of this H2C6H8O4, and I'm going to multiply it by the molar mass of what the mass is of 1 mole of adipic acid. So I'll write down here for every 1 mole of C6H8, I forgot the H2O4, what mass do I have? I'm going to figure that out on the side. I figured that out up here on the side. Came up with 146.16 grams. Hopefully I didn't make a mistake. For every 1 mole of adipic acid, I have 146.16 grams. If I multiply that ratio by the number of moles I actually have, I'll get the mass that I actually have, which ends up being 43.50 grams of adipic acid with 3 sig figs. That would be 43.5. So that is the mass of adipic acid that we would get. That's the theoretical yield, the amount that we would get if we used up all of our limiting reactant. Okay. So now, the second part of the question, because we have to see if we're done, we've answered part A. Part B says if we obtain something, I can't read this, hold on, 33.5, if we obtain 33.5 grams of adipic acid, what is the percent yield for the reaction? So we're going to go to the next page for this problem. Next page, go. So if we have, remember percent yield equals actual yield divided by theoretical yield, and to make it a percent, you multiply it by 100. So our actual yield, they're telling us, in this case, is 33.5 grams, and we calculated in the previous page 43.5 grams as our theoretical yield. So we need to divide that ratio, multiply by 100, and we will find our percent yield. I come up with 77.0% as our percent yield. Now in your homework problem sets, you may be given the percent yield, let's circle it in purple, and you may be given the theoretical yield and asked to find the actual yield. And you can do that because you'll know 2 out of 3 things in this equation. You'll only have one variable. Or you may be given the actual yield and the percent yield and asked to find the theoretical. If you only have one variable, you can solve for the variable if you know the rest of the equation. So that'll come up in your problem set for homework. So this is the first, there's going to be one more video where we're going to talk about another type of problem.